Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be going over how to apply the reciprocal property of exponents. This standard is covered in Algebra 1, 2, and Pre-Calculus. Don't forget there are 6 practice problems at the end of this presentation that we'll like you to try out to demonstrate your understanding and mastery of the concepts we covered in our examples. If you'd like to gain access to the entire playlists, the course lists, and other valuable learning resources, just take a look at the link in the description below or visit our website at mathgotserved.com. If what you're looking for is not available there, just let us know what you need in the comment section and we'll be glad to assist. To get us started, let's take a look at the reciprocal property of exponents formula. So the formula for the reciprocal property of exponents is as follows. If you have x raised to negative a, this is equal to 1 over x to the a power. Alright, so this is the formula that we're going to be using to guide our reciprocation process in the examples that we're going to be doing. Alright, so if you take a look at this formula for a second, look at the left side and the right side. Do you notice the differences between our exponent terms? Well, if you take a look at the left side, you notice that x has a negative exponent and it is in the numerator position. But on the right side, x has a positive exponent, but instead of numerator, it is now in the denominator position. Another way to think about the reciprocal property is the flip property of exponents. What does that mean? If a term with a negative exponent is in the numerator, it gets flipped to the denominator. And if a term with a negative exponent is in the denominator, it gets flipped to the numerator. Okay, so by extension, we can write something like this. 1 over x to the negative a is equal to what? X to the a power. So that negativity is what causes a term to get reciprocated. Okay, and upon reciprocation, that negative sign goes away. So keep that in mind. All right, let's take a look at some examples. The instructions are as follows. We are to simplify the following. Expressing answers with positive exponents only. All right, let's take a look at number 1. What if we have y raised to the negative 3 power? How do we do this? Have y raised to the negative 3 power. All right, so we have y to the negative 3rd power. So the only term with the negative exponent is the y term, okay? So what does that mean? Using the reciprocal property of exponents, y is going to get reciprocated. So y to the negative 3rd is simply going to become 1 over y. And when we reciprocate, this negative power becomes positive. And that's the answer to question number 1. All right, let's take a look at another example. What if we have something like this? What if we had 5m raised to the negative 3 power y to the negative 2 power? All right, so we want to simplify that, writing all the terms with positive exponents. So we have 5m to the negative 3, y to the negative 2. Now something to keep in mind. All right, let's take a look at question 4. For problem 4, what if we were to simplify the quantity 3x to the third y square z to the fourth all raised to the negative 2 power? Okay, all right, let's do it. So we have 3x to the third y square z to the fourth raised to the negative 2 power. So what we're going to do first is we're going to apply the power of product of powers property here to resolve this parenthesis situation. Okay, so in the parentheses, let's specify the powers that every term has. So 3 has the invisible power, which is 1. X has a power of 3, y squared z to the fourth. Now this power on the outside, we're going to distribute it to all the powers on the inside, okay? So we're going to have negative 2 times positive 1, negative 2 times positive 3, negative 2 times positive 2, and then negative 2 times positive 4. All right, this is known as the power of a product of powers property of exponents. All right, so when we distribute that out, we're going to now have 3 raised to the negative 2 x raised to the, so negative 2 times 6 is times 3, sorry, is negative 6. Y raised to the negative 2 times 2 is negative 4. And then z raised to the 4 times negative 2 is negative 8. Okay, so what do you notice happening here? You notice that every single factor here has a negative power, which means that everything will get reciprocated. All right, so when we reciprocate every single thing, we're just going to be left with 1 in the numerator position. And then in the denominator position, we are going to have 3 raised to the second power, x to the sixth power, y to the fourth, z to the eighth. So all the terms with negative exponents got reciprocated to the denominator position. All right, we can simplify 3 squared further. So let's go ahead and do that. Move this down a little bit. If we simplify 3 squared further, we're going to have 1 over here, 1 over, so 3 squared is 9, 9x to the sixth power, y to the fourth power, z to the eighth power. Ladies and gentlemen, that is the answer to question number 4. All right, let's take a look at the next one, question 5. So for question 5, what if we're to simplify the product negative 5x to the third times negative 6x to the negative fourth power? Let's take a look at this one. So let's rewrite it. So we have negative 5x to the third times negative 6x to the negative fourth. Okay, there are 2 ways you can do this. You can use the product property of exponents, or you can use the reciprocal property of exponents. You end up with the same answer. So what I'm going to do here is I'm going to use the reciprocal property of exponents along with the quotient property of exponents to solve this one. Okay. You could do this using the product and the reciprocal property. You'll get the same answer. Now, negative 5 and 6 both have powers of 1, the invisible power, so we can multiply those two numbers together. Negative 5 times negative 6 is positive 30. Positive 30x to the third. Now, this x to the negative fourth has a negative power, so how do we rectify the negativity of the exponent? What we're going to do, since it's being multiplied, is still a factor of this product right here. We're going to reciprocate it, okay? So it's going to go x to the fourth power. See that? All right, now we can now use the quotient property of exponents to finish this off. Since we have exponents with the same base being divided by one another, we can use the quotient property of exponents. So let's just highlight what that is here. If you have x to the a over x to the b, it's going to be x to the a minus b. Okay? All right. Here we're going to apply the reciprocal property of exponents. But what we're going to do is we want to do it in the quickest way. So to do that, we're going to identify which exponent has the bigger power, and that will be the dominant exponent. Okay, so x to the fourth and x to the third, the denominator has a high exponent, so this will dominate. So what we're going to do here is we're going to subtract this power, the smaller power, from the bigger one. Okay, so x to the third is smaller than x to the fourth, so it gets taken out completely, but you subtract its power from the power of the denominator. All right, that's the quotient property of exponents. We went over this in previous presentations. So if you want to go over the quotient property of exponents, you can just take a look at the playlist and you can see how that is done. Okay? All right, so that's 30 over x to the 4 minus 3 is just 1. All right, so our final answer is 30 divided by x. All right, let's take a look at question number 6. So for question 6, let's say we have the following product of exponents. What if we have the quantity 3x to the fourth, y to the negative third, z to the third, multiplied by 2x to the negative 3, y to the fifth, z to the negative 2. Okay, let's go ahead and do that. All right, so if we have this product right here be multiplied by each other, since we're multiplying, we can simply express them as a product of factors. All right, you can drop the parentheses. So this basically becomes 3 times x to the fourth times y to the negative 3 times z to the third times 2 times x to the negative 3 times y to the fifth times z to the negative second power. Okay, so these are all factors. So what we're going to do is we're going to reciprocate the terms that have negative exponents and then combine terms that we can combine in the numerator. Okay, that's one way of doing it. You can also use the product property of exponents to just combine like terms and reciprocate where applicable. All right, so let's do reciprocation first, and then we are going to use the the quotient property to finish it off. Alrighty, so 3 and 2 are like terms, so we can multiply those two to give us 6. And then x to the fourth has a positive power, so it stays upstairs. Y to the negative 3 has a negative power, so it gets reciprocated, and the power becomes positive. And then z to the third, let's see, is there another y here? Yeah, y to the fifth, you see this y to the fifth here has a positive power, so that stays up. And then we have z to the third right here stays upstairs. Okay, x to the negative 3 has a negative power, so it comes down. Let's put it in front, so it's x to the third. And then lastly, z to the negative 2 has a negative power, so it comes downstairs. All right, so the terms with negative exponents are y to the negative third, you see down here, x to the negative third, you see down here, and z to the negative 2, you see down here. All those three got reciprocated. Okay, everything else are upstairs. 3 times 2 gave us the 6. We brought down x to the fourth, y to the fifth, z to the third. Okay, we're just trying to preserve alphabetical order here. And you know that multiplication commutes. The order that you write a multiplication of factors does not matter. Okay? All right, let's finish this up. So we're going to use the the quotient property of exponents. So 6 has nothing to battle with. And the x's, we have x to the third on the bottom and x to the fourth. So we subtract the smaller from the bigger and cancel it out. So 3 is smaller than 4. So we subtract that power there, and this is taken out completely. That's equivalent to dividing by x to the third on the top and bottom, okay? So that's going to leave us with x to the first power. And then the y's, which one is smaller? Y to the third is smaller than y to the fifth, so y to the third is divided out completely on the bottom, and on the top you minus 3 from that power, and that gives us y to the 5 minus 3, 2. Okay, and then we have the z's, z to the third and z squared on the bottom. The bottom is weaker again, so that gets taken out, and then you subtract the power from the top, and then you have z raised to the first power. All right, so your final answer is going to be 6x y to the second power z. Okay, so that is the answer to question number 6. All right, we'd like you to go ahead and try out these practice problems. So what you're going to do is pause this presentation at this time. So go ahead and try out these problems, and then when you're done, click on the playback button and the answers will be displayed. All right, hopefully you had the chance to try out the problems. Let's take a look at what the answers are. For question number 1, the answer is 1 over x to the 5th power. For number 2, the answer is 5 over m to the 3rd y square. For number 3, the answer is negative 5 bc square divided by a to the 4th. And then for number 4, the answer is positive 12 over y to the 3rd power. Okay, for number 5, the answer is 1 over 2 squared, which is 4, x to the 4th, y to the 2nd power, z to the 4th power. And then for number 6, the answer is 8 over a square b c. Okay? All right, so how well did you do with these practice problems? Let us know in the comment section below if there are any questions, concerns, or anything you'd like us to clarify on these examples. Just let us know in the comment section below and we'll be more than glad to respond. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your studies of exponents, do give us a like or a thumbs up. Your positive feedback is very valuable to us. Don't forget to subscribe to our channel for updates to other presentations such as this. As indicated earlier, if you have any questions, comments, just place it in the comment section below and we will be more than glad to respond. If you'd like to gain access to more support resources, do visit our website at Mathgotserved.com. Thanks again for watching and have a wonderful day. Goodbye.